Making a Sawtooth Banding, adapted from the DVD Making a Portsmouth, New Hampshire Gallery Table. To see this and other titles, please visit my website at www.americanfederalperiod.com. This is the start of the sawtooth or triangular banding that runs around the perimeter of the drawer front. And I'll probably use the term sawtooth and triangular banding interchangeably. And it's a very simple inlay to make, but it does take some time. I've spent over an hour cutting a series of V-grooves in this piece of wood. And this piece of wood is made up of, it was supposed to be a 1/4 inch thick. I got a little carried away with the surface planer, so it's about a 64th under that. That really won't matter. The banding will end up looking exactly the same because of the way it's constructed, but I would have liked to have it come out the proper thickness. And it's satin wood, about 1 inch wide, and ebony, about 1 inch wide. And then at the heart of it is this jig, and like all the jigs that I make, it's very crude. I despise jig making. It's a piece of plywood and 2 guides, and the guides are approximately 1/64th of an inch thicker than the banding, and that was on purpose that it was a 64th thicker. And they are spaced apart, just leaving a little bit of room here for dust and whatever, and for just so it's easy to slide. And then at an exact right angle, and it's important that this is perfectly square to this here, I have 2 guides, and they're spaced apart so they match the width of the base of the router. And then there's a block of wood, you can hardly see it, but there's a block of wood underneath that is clamped in the vise and also gives a place to apply the clamp that holds the piece in place as you're doing the routing. And then so that it doesn't kick in this direction, I've got a 2x4 just clamped to the bench. And fitted in the router is a 120-degree V-bit. And I have the router hooked up to the shop vac because this generates, as you can imagine, quite a bit of dust. And also to lessen the wear and tear on the switch for the router, I have it hooked up to a foot switch, but you have to be very careful with that you don't inadvertently step on the switch when you don't mean to. And it couldn't be simpler to do. You just have to route the groove, then move it a certain amount forward, and I'll show you that in just a minute, how you gauge that. And then we'll just repeat that process until you've gone the full length, and the piece I have here is about 37 of an inches long. So I'll go ahead and put on my safety equipment, turn on the dust collector, and route one of the grooves. This is a close-up view showing the indexing mark on the jig that establishes the spacing, and you're looking at it from the side that the router feeds towards, so the router would be feeding in that direction. And to give you an idea of the scale, there's the tip of my pinky right there, so it's quite small what we're looking at here. And the indexing mark that is used to establish the spacing is right there below the pointer. And you, at first, when the jig is brand new, you can use this V-groove here that's formed by the router to establish the spacing. What I did was I took and routed the groove with just the guides in place, no material in place. Then I put the material in place and routed the V-groove, and I slid that V-groove over until where it transitions from flat to the start of the V-groove lined up from on here where the V-groove is in the guide. When those 2 points contacted one another, then I took at the bottom of that valley and made the scribe line. But with use, and this jig has only been used for about, well, just for this one piece, and the run out and the slight bit of slop that is inherent between the guides for the router results in this groove growing over time, so you can't use it more than just right at the beginning, or you would have inaccuracies. Now with this sawtooth inlay, the spacing's not critically important. The way that the pieces will be sawn apart and put back together allows for quite a bit of slop in the spacing. But if I were making a diamond banding, it would be critically important, especially on the second go around, that I had accurate spacing. And when I was milling up the stock for this, I milled up a scrap piece, and I used that for the setup because you want to cut halfway through the material when you're cutting this V-groove. But that's complicated by the fact you can see that very small flat that's at the bottom of each groove, and that's inherent in the nature of the carbide used in the router bit. Carbide can't be ground to a very sharp point, it's just too fragile. So when you set that depth, you have to do a little bit of guesstimating because you have that flat there. And that flat will be dealt with here in just a moment, you'll see that. So this is now set up to cut the next V-groove right in this area here. To remove that flat at the bottom of the V-grooves, I'm going to use a V-gouge. The V-gouge doesn't have to accurately match the angle, the 120-degree angle of the router bit. Anything to just remove that slight flat there at the bottom. I imagine you could even use a small needle triangle file if you needed to. And it couldn't be simpler. Just, it's a little bit hard to start, so you want to make sure that you start all the way back at the end, especially in the ebony. In your gouge has to, or your V-chisel has to be perfectly sharp. Now the pieces are going to be sawn apart at the joint between the satinwood and the ebony. Now comes my favorite part. The pieces have been sawn apart, but they're how they were oriented when they were glued together. And it's time to now close them like closing a book. And the pieces should nest together almost perfectly with just finger pressure. And it does all the way down to that end, but I have a little bit of a problem area right in here. Got one that doesn't seem to want to close up with just finger pressure. So sometimes offsetting it in one direction or the other will change things. And that looks good all the way down there, and it significantly improved the fit here. And under pressure, under clamping pressure, that will undoubtedly go together perfectly. So now it's time to get out the glue and the clamps. This is a somewhat fragile inlay, and ebony is not the best wood for gluing, so I'm going to put a considerable amount of glue on here, and I'm really going to crank down on the clamps because it's necessary to ensure that they are in firm contact with one another. Now once the inlay is glued in place, it will be sufficiently strong, but even the sandwiching veneers will leave this inlay somewhat fragile in its block form. Spread a nice even coat. Got to work here some at the ends. I'm just going to apply it to the one. I don't need to apply it to both pieces. I'm going to brush this glue out and then put on the clamps and alternate them up and down for ease of application. That way the handles aren't in each other's way when you're trying to tighten them down. Here's the banding as it comes out of the clamps, and it's kind of hard to see, but the sawtooth pattern will emerge when the satinwood and ebony are cut away until you can see the peaks of the contrasting wood showing through. And right now there's probably close to, well, maybe a little less than an eighth, 3/32 I guess, to remove on each side. And in the past I have planed that away, and that can be somewhat difficult because, like I say, this is not the most substantial piece. Right now it is, but when you plane away part of the other section, it can get somewhat fragile. So I'm going to take and saw away part of it here on the bandsaw, then thickness sand it until I see those peaks showing through, then flip it around and repeat the process for the other side. And those components are going to be sanded to a precise thickness here at the drill press using this fixture that I built. It consists of a table made of 2 pieces of plywood. The upper piece of plywood has a hole drilled in it for clearance for the sanding drum. And down below the sanding drum, you can't see it, but there's a bearing that I purchased at Lee Valley, and that eliminates or reduces any run out from the sanding action, because as the piece is pushed here against the fence, it'd have a tendency to push the arbor out this way and cause some run out, and then it would lead to inaccuracies. And the sanding drum itself is something that I made. I purchased the arbor and I drilled a hole in a block of wood and epoxied the arbor in there and then turned it on the lathe. And then a slot was sawed in the side, and a hard or a softwood block is forced in there to hold the sanding sleeve in place. And just as added precaution, I put a small wood screw in there just so something didn't fly out as it's running. And the fence is simply a piece of wood just made so that it's perfectly parallel to the sanding drum. An adjustment is accomplished rather crudely by tapping in one direction or another with a small mallet. And as you can imagine, this generates a considerable amount of dust, so I have the dust collector hose hooked up here. Here at the drill press mounted thickness sander, I have taken and sanded away the ebony until you can see the peaks of the satinwood showing through. And now I'm almost to that point on the satinwood side. You can just barely start to see peaks of ebony showing through right in this area. So I'm going to make a couple more passes. What I'll do is I'll take a pass, see how I'm doing, and then for the final pass I will reverse it and run it through in the opposite direction. That will even out any variations if the sanding drum and the fence aren't exactly parallel to each other. But when I'm done, this should probably vary no more than a couple 3/1000ths of an inch over its entire length and width. It's that accurate, this sanding fixture is. The banding is dried overnight. Now it's time to take it out of the clamps. You can see the number of clamps that are required to ensure a good bond between the sandwich veneers and the individual components. I've got them placed about every 2 inches or so, and I alternate them up and down so that it's a little easier to tighten them. After assembling the inlay, I went back and tightened up the clamps after about, maybe 5 minutes or so, and I really gave them a good hard twist. Normally I don't like to apply a lot of clamping pressure. I figure if you need to apply that much clamping pressure, you've done something wrong. But in this case, I feel that it will slightly compress the wet pieces and they'll come out just a little undersized. And then when the glue is used to install the inlay, they'll swell back up and fit the groove very precisely. Now, when the banding comes out of the clamps, it's going to look quite poor. It may have been stuck in some places to the clamping board slightly, and the edges will be very rough, but it's always fun to see it come out of the clamps and get the first look at it the way it's going to appear. It's kind of a neat thing to see the pattern emerge. I really torqued these down. Well, it didn't stick at all. Sometimes the glue will seep through. It stuck a little bit there. But now we have the banding. Once the banding had come out of the clamps, one edge was planed straight and then the other edge was ripped on the table saw, taking off just enough to have it come up clean. And then it was glued to this piece of pine, and this piece of pine here acts as a handle. It keeps your fingers safely away from the blade as you're ripping off the individual strips, and it also allows you to get the maximum yield out of it. This way you can use almost all of the banding up, and that's important when you consider the amount of time that it takes to produce these bandings. And in keeping with that, I have fitted the bandsaw with a blade from Starrett. It's 14/1000ths of an inch thick, so that's quite a bit thinner than a normal blade. It has a rather coarse pitch at 6 teeth, and it's 3/8 of an inch wide. I'd rather have a finer pitch blade, but this is the finest they make them in. And so to counteract that kind of coarseness of that blade, I have fitted the cable with this auxiliary cable. It's made out of a piece of oak plywood, and it has a saw cut in it, and in effect makes it a zero clearance insert, much like you would have on a table saw. And when you consider that the individual bandings being ripped off are sometimes around 30/1000ths to 40/1000ths of an inch thick, this particular one here is right around 40/1000ths thick. If you had a 25/1000ths thick bandsaw blade, you're wasting approximately half of your banding as sawdust. So by using this blade, you can get a few more pieces per inch out of your banding, and that's a good thing. And this will make, despite its coarseness, it makes a very good clean cut, And depending on the application of the banding, I will either just rip off one strip after another, or I will plane in between cuts. This particular banding, since it's going to be laid into a rabbet around the edge of a drawer front, I took and ripped a strip off, planed away the saw marks, ripped a strip off, so on and so on. And then when I glue it down, I will glue down the planed face, because that's going to have the absolute best glue surface that's available.